So today, let's see, a couple announcements before we get started. Don't forget, Project 3 is due on Friday at 11:59 p.m. Also, please fill out the course evaluation forms. You should have received a course evaluation form from the campus. If 80% of the class fills out the course evaluation form, we're giving you, I think, 2 points on the final. And homework is due on Friday as well. All right, so this week we're doing no major new material. This is wrap up and case studies. And what I wanted to do today is talk about privacy. So we've done a lot of technical content in this course, and I think it's also important for you to see a little bit about some of the social implications of the technology we're showing you. And so today I wanted to just talk about privacy. This is one of my areas of research. I work on privacy and computer security. So it's a topic that's near and dear to my heart. And my hope here today is to expose you to some of the issues, so that in your future life as a data scientist, you can be aware and think about some of the privacy issues that could come up. Okay, so let me give you a little bit of a primer background on privacy. I think this is an issue that may face your generation even more than my generation. Let's see. Does anyone know what this is a picture of? Yeah, that's Zuck in Congress, right? From 2018. Does anyone know why he was called up to Congress in 2018? Privacy breach. Yeah, Cambridge Analytica. Ah, there's someone who remembers. Yeah, Cambridge Analytica, big scandal. Show a magic trick. Maybe it would have gone better if he'd started out that way. The Cambridge Analytica scandal. Yeah. Have you heard of that one? It's maybe a little obscure, unless you're in the privacy world, in case you know a lot about this. What happened in the Cambridge Analytica scandal? Maybe none of you are familiar. Okay, so in the Cambridge Analytical scandal, what happened was it was discovered this company called Cambridge Analytica. It was a British company, had gained access to personal information, private information from people's Facebook accounts, from something like maybe 50 million Facebook users. And this was a company, they were advertising that they could use this for very precise voter targeting and election campaigns. And they had announced some clients, including I think it was maybe the Leave side of the Brexit, and maybe it was Ted Cruz's campaign and a couple others. And in retrospect, it wasn't so clear whether their targeting was actually all that effective, but they really did have data. They got data on 50 private information from 50 million Facebook users' profiles. Stuff that those users had not wanted to release to anyone else. So how did they get that information? Well, basically because Facebook was a little bit lax in how they enforced those privacy settings. So back in 2014, 2015, this British academic created an app. It was a survey. You could install this app and, like, I don't know, take some survey to learn something about yourself. But what the app didn't mention when you installed it is that it downloaded your personal information, private information from your Facebook profile, but not only yours, but all of your friends. Because you see, at the time, Facebook apps were allowed to access, if you install a Facebook app, it was allowed to access not only your private information, but also the private information of your friends, even though your friends hadn't installed the app or heard of it or done anything to consent to this, merely because you had ability to view that non-public information of your friends, then the app got the ability to view it too. This person managed to get several 100,000 Facebook users to sign up for the app and take the survey, and it's kind of neat. You like find out something about yourself, and amassed data on 50 million Facebook users without their consent. And then he turned around and he sold it to a company. This company, Cambridge Analytica, bought it, and they decided to commercialize it for advertising and targeting voters and get out the vote campaigns. And Facebook basically didn't prevent this, didn't do anything to prevent this, and so they got in the news because there were a lot of Facebook users who said, why does this random company I've never heard of have my data? So this is one that has a particular personal resonance to me, because one of my grad students, the grad students in my group, Adrienne Porter Felt, when she started as a grad student, she was telling me about Facebook and privacy. I didn't have a Facebook account at the time. And she was saying, I got interested in building a Facebook app, and I discovered that their privacy and security settings are really lax, that apps can gain access to your personal information and your friends' personal information. That doesn't seem right. And she wrote a paper about it and sent it to Facebook and said, hey, this is broken. This is a big privacy risk. You should fix this. And Facebook didn't do anything. Nothing happened. She wrote a paper, warned about it. And several years later, we learned of this scandal, that in fact, it was not just a risk, but it had actually been exploited. All right, so kind of an example of privacy failures. And I think we'll see more and more failures like this. Okay, so why do we care? There's an interesting research study that I thought you might find kind of intriguing, that found that if someone has access to, can view what things you've liked on Facebook, they can learn a lot of stuff about you that you might not have anticipated. So for instance, this research project found that by looking at your likes, they could guess your race, in particular, predict whether you're white or black. And they were able to predict that with 95% accuracy. So they basically we've been looking at machine learning. They took a machine learning classifier and they used likes and used that to predict the person's race. They were able to predict your political leanings, whether you consider yourself a Republican or a Democrat, with 85% accuracy based on your likes. That's kind of not surprising. If you're liking Fox News, maybe you're more likely to be a Republican. If you're liking articles on the New York Times, maybe you're more likely to be a Democrat, and so on. And they even got some other ones that kind of surprised me. They could tell, they could predict Christian versus Muslim with 82% accuracy from your likes. And one reason why that might be concerning, this is not something that most people enter into their Facebook profiles. So you would think that Facebook has no idea of what your religion is, but the fact that they can infer this, or anyone else who gains access to this like data could infer it, is maybe a little surprising and maybe a little worrisome. I remember, I don't know if any of you remember this, about 4 years ago, there was a proposal that had been, was making the national news, that there were some politicians who were advocating for creating a registry of all Muslims in the US. And all Muslims would have to register on this national registry, which I found really alarming, right? I mean, it brings to mind, the Jews having to register, concerns guns rights activists have about everybody who owns a gun having to register, and then guns being taken away. How is this information going to be used? This could be used as an instrument of control, discrimination, Japanese internment camps. Absolutely, we have a long history of this kind of stuff leading to really bad outcomes. And so you might think, no big deal. How is the government going to know who's Muslim versus not? If they set up this register, all you have to do is just not report yourself. But no, what I think one of the points this makes is that it's important to understand about the capabilities of the technology is that, in fact, there's data out there in, like data that Facebook has, that could be used to infer and identify an awful lot of Muslims. And so what might sound like an infeasible idea is actually technically maybe more feasible than most people might realize. And so you can't count on, oh, that's impossible, well, you could never implement it to actually be your safety measure against that. Also found that from likes you could predict orientation, homosexual versus heterosexual for males. So that was surprising. You know, if you're not out, that Facebook could know or infer whether you're gay or not. Might be a little concerning. So this is an example of inference, that one of the challenges we find in the privacy world is that it's kind of obvious. If I tell Facebook my birthday, then they know my birthday, and then I'm reliant on them, to not share it with anyone I don't want. But what might not be obvious is by sharing one kind of data, it allows inferences to be made that could infer other information about me that I haven't chosen to reveal. And so this is one of the challenges of privacy and one of the risks introduced by machine learning. The machine learning can be used to draw these inferences with surprising accuracy. And we can start to see, kind of hints of what could become possible. So for instance, in China, there are provinces in China that are starting to experiment with social trustworthiness scoring systems, where every citizen gets a trustworthiness score. And your score affects whether you get loans, your interactions with the government, maybe whether you get government services, whether you can travel. And that score is based on all sorts of stuff, like what you do for the community, but potentially also other actions. I mean, you could really imagine how this could be. You could imagine it could be a beneficial thing, but you could also imagine it could be a really powerful tool for social control. And if anyone's familiar with talked about internment camps, the treatment of Uyghurs in China. There, it's really talk about Black Mirror stuff, like dystopian stuff going on there, from what I understand, of a control of this minority that's viewed as a threat to the government, and restrictions on movement. And one of the things that's happening there is that we're seeing increasing use of machine learning as a tool of social control. So for instance, there are cameras on every street corner that's using machine learning, facial recognition, and other machine learning algorithms to identify all the people who are walking down the street. And they have a registry of which people are in the Uyghur minority. Stuff like if they see a gathering of multiple Uyghurs going to the same block who don't live there, then the police receive an alert that there may be some kind of an uprising happening there, or a meeting, an unapproved meeting of just amazing stuff. So scary, the potential for how technology and these techniques we've been teaching you could be used for harm. And that's enabled by having a lot of data about the citizenry. So data on which individuals are in this minority or not, on their actions, data gathered from their phones, on their movements, on where they live, on who they have contact with, who their family is, where the pressure points are that can be used to exert control. Here's another example of what are the stakes of privacy. A really interesting experiment done by Facebook with really good intentions, really fascinating, but also a little scary when you think about the implications. They did an experiment a couple of years back on encouraging people to vote. And they did an experiment where they showed, did this randomized experiment where half of the people saw message 1 and half of the people saw message 2. So on election day, the people who were in group 1 saw a message on their Facebook feed that said, "Hey, it's election day, you should go vote." And the people in group 2 saw a message that said, "Hey, it's election day, you should go vote." And also a thumbnail image of some of their friends who had already voted. And Facebook has an idea how you voted, because if you report on there, you voted, you click I voted, then now they know that. And what they found in this experiment was that they were able to increase turnout using this. And in fact, out of the 61 million people they showed this to, 340,000 more voted when they saw a message of variant 2. So this is an example like A/B testing kind of thing. And so that's like, what is that? Maybe 1% increase in turnout. They were able to drive just by this very simple messaging. So that sounds really great. I mean, if we could use technology to help people turn out for elections and increase, participation in democracy, that'd be awesome. But it's also a little scary because if Facebook were somehow to turn malicious, this could actually be used in harmful ways. Like, for instance, Facebook probably has a pretty good idea how you're likely to vote, from demographics, from likes, from all sorts of stuff. And if they started targeting some populations of people to get messages to vote and other populations to not, they could influence the turnout in the election and maybe influence an election. Or maybe not Facebook, maybe some other organizations that are just using advertising through Facebook and paying Facebook for the ability to maximize turnout of their targeted voters, then this is kind of creating machinery that can be used to influence people that could have interesting implications. And by the way, for those of you who are following the disinformation, Russian disinformation in the 2016 election, we already start to saw nation states exploiting much cruder versions of this. So in 2016, Russian hackers started trying to disrupt the election and decrease trust in the outcome. And they went after a number of candidates, both Republicans and Democrats. And there's a really interesting report from, I think it's the Senate, or maybe it was the House Intelligence Committee. And one of the things I found fascinating in there, everyone talks about how the Russians were trying to, or weren't trying to help Trump, but it wasn't just Trump. And moreover, it wasn't just helping a candidate. Actually, it looks like one of the things they were trying to do was spread distrust to divide the nation. Also they had this divisive messaging, and they specifically, especially went after Blacks, and they were targeting their messaging to create divisions within the Black community. And so what we're seeing basically is a weaponization of disinformation by external nation states. They're using it to exacerbate political divides that already exist in this country and heighten divisiveness as a way to try to disable us or make us less effective on the international stage. So it's kind of scary to see the potential for using this data to manipulate American democracy. All right. Here's another interesting study that I thought you might find interesting. In, I don't know, more than 5 years ago, Netflix had a really interesting public challenge where they said, we're trying to improve our recommendation systems. You watch a movie and Netflix will recommend a couple others you might like based on how you rated movies in the past. And they said, our recommendation system is okay, but it's not great. We wish it could be better. Here's a public contest. We want you to come up with new and better ways to make recommendations. So they were using machine learning, and they said, maybe there's a better way. Let's harness, the intelligence of all the machine learning people across the world. And they announced some huge prize if you found that for the winner of this competition to come up with the best recommendations. And they reached a giant data set to help machine learning researchers study this. Data set of a whole bunch of Netflix users, millions of Netflix users, and what movies they rated and how they rated them. To protect the privacy of the Netflix users, they anonymized it. So they didn't include the name of each of those users. They just had, user 2735. Here's all the movies they watched and all the ratings of all those movies and how they rated them. Okay. So they figured that takes care of the privacy issue. And then security and privacy researchers discovered, no, it doesn't take care of the privacy issue. They discovered that if I know 2 of your ratings, and when you rated them, that's enough to uniquely identify you in this data set for like 2/3 of people. So for instance, if you had publicly rated a movie on Amazon with a review under your own name, or on IMDb or any other reviewing site, and you used your real name, you posted 2 reviews on two movies, we could look at the date and the star rating you gave it, match that up to this data set, and for 2/3 of people could figure out who you were uniquely, and then figure out all the other movies you watched and how you rated them. And maybe there's some others you didn't want people to know that you were liking, your guilty pleasure. All right. So what this highlighted was the myth of anonymization, that just because I remove your name from a data set doesn't mean that we've eliminated the privacy issues. And this is particularly relevant in the medical world, where scientists would like access to medical records. But for privacy reasons, we don't want to give them, well, all of your medical records with your names and maybe the embarrassing medical situations you've got, and like the names of everyone with HIV or with cancer or whatever. But yet having this data would be really useful. So for the first attempt people make is they remove the names, but they hand over the medical records, and we've been discovering that isn't enough to conceal the identity of the people that the data is about. So there's some real privacy challenges here in how you provide anonymized access to data. So there's a couple of themes from these that I wanted to highlight for you from these examples. Is the notion of disclosure, collection, and inference. How can a company come to learn something about you? One way is you disclose information to them. You tell them your birth date. Another is a collection. That's, you didn't explicitly tell them, but they observed you. So an example of this would be when you're browsing around the web, advertising companies have ads stuck on the web pages. And if you go to a web page that has an ad in it, the advertising company is observing what you do on that page. If you go to Google, they're observing what search terms you enter in. If you click on a link that takes you to a page, maybe you're trying to investigate vacations, and you click on a link to a cruise ship that has a Hawaiian cruise. If there's an ad on that page, then the ad company learns that you were interested in Hawaiian cruises, and maybe they even learned the search term that you entered in. And then if you later that day go to a website for some totally other thing, go look at a New York Times article or something, and there's an ad on there from the same ad company, the ad can remember it's you again, use the cookies to identify that's you, and that you were interested in Hawaiian cruises before, so maybe I should show you an ad for other kinds of cruises. Okay, so that's collection. And then there's inference, where they've collected data, one kind of data about you, like what news sites, what news articles you like to read, and draw some inferences, like from that, what your political party might be or what your religion might be, and then try to target you based on that inferences, using typically inferences done using machine learning. Okay. So 3 different notions that raise different privacy challenges. Disclosure, I think, has the least privacy implications, because when you disclose something, you know that you're revealing it and you make a choice to do that. Collection, a little more challenging because it's happening silently and you might not be aware of it. You might not have chosen that you want to reveal that information. And inference, particularly tricky, because most people who are not privacy experts would not think about what could be inferred about them given what could be collected. And so it's just, we're not very good at thinking about that. So it's very hard to anticipate what kind of information people might have about us, be able to learn about us using inference techniques. What is privacy? There's a couple of different, it's a lot of different ways to think about what privacy concerns, how to think about privacy. If you want to protect the privacy of your users, if you were the steward of a large data set, what might the privacy issues might be? So I'll give you a couple of different perspectives that are out there in the literature. One is a view from, it's an old view from these Supreme Court justices, Warren and Brandeis, where they wrote a famous Supreme Court decision, and they define privacy as the right to be left alone. So basically they're talking about like not having a solicitor knock on your door and interrupt you and bother you. So that's one view of privacy. Another view of privacy is about control. It's about, what control do I have on who can obtain information about me or who can use information about me? Do I have control? Can I, for instance, if I have cancer, can I limit who comes to know that? Maybe I just don't want to have that kind of discussion, or I notice that interactions go in a different direction when people learn that I have cancer, and so maybe I'm tired of that. And there's some people I want to know this, and some people I don't want to know that. Can I control who knows that? Okay, so that's another conception of privacy. It's about control that you have. Another notion that's come from the government world, a kind of bureaucratic compliance notion, is in the US, we have this notion of fair information practices, which are a fairly limited notion of privacy. but these are principles that suggest notice. Do people have a chance to be informed that data is being collected about them? Consent. Do people have a chance to consent? So for instance, in the medical world, before your data is shared, you are asked for consent. And if you go ask for surgery, they're going to ask not just for consent, but informed consent. They're going to try to inform you about all the implications of your decision, and then do you want the surgery or not? And lastly, access. Can you find out what data a company has about you? So if your credit record, for instance, you can obtain a copy of your credit record. Okay, so that'd be an example of access. So maybe you can't control what they're doing with or what information they have of you, but at least there's some transparency that you know what information they have. And consent, sometimes people talk about opt-in consent versus opt-out consent. Opt-in consent is where you ask people for explicit approval to collect information from them. And if they say no, you don't collect the information. Opt-out is the reverse. I'm going to be collecting information about you. If you don't like it, you can let me know. But if you don't say anything, I'm going to collect it. So for instance, that might be, a sign saying you're being recorded. If you don't like it, go away. Okay, so this is a fairly limited notion of privacy. Those are some principles you could try to follow if you were building a system that's collecting sensitive information about people. Another notion from the philosopher Helen Nissenbaum has been influential lately, is she calls it contextual integrity, which is a mouthful that kind of doesn't mean anything, but at least those words, when I first heard that, I thought, what does that mean? What she means is that basically privacy is about social norms and expectations, and about the context. So it's about people's expectations, basically. That if I go to the bar with a buddy of mine and we're having a beer and I tell him about some problems I'm having, then I have an expectation that that's kind of between us, right? I don't need to say anything. I don't need to tell him, but this is just, that's the context of that conversation. That's where it's happening. And, kind of everyone understands that, if he was to go then, I don't know, post to the world, hey, Dave's having these problems, that would be a violation of our expectations. That's not what we expect to have happen. So, where people feel most strongly, Helen Nissenbaum suggests, is where information that's disclosed in one context, kind of with one expectation, one purpose, then gets used in this totally other way that's unexpected and it's kind of outside the social norms for what people would anticipate. Okay, so that's another way you could think about privacy. And there's a lot of the privacy concerns that we're talking about now in data science is about informational privacy. It's about what information is revealed about you. And where that comes in is it kind of comes into self-autonomy. Can you control the persona you present? In a professional world, we present one persona. In a private, we present another one. I don't know. Can I choose my own image or my branding? Why might you care about privacy? One of those reasons, well, one is kind of maintaining social boundaries. I don't necessarily want everyone to know everything about me. Different people, I disclose different things because that's the nature of the relationship. Another reason people are concerned about privacy is limits on power. It's about like the power of the government over me. Like if they know that I am a minority, are they going to, discriminate against me? If I know that I own a gun, are they going to come confiscate it? Or it might be about limits on commercial power, what companies could do, how they might try to influence me or treat me if they know things about me. It might be about freedom of speech, of thought, of politics, of opportunities for second chances. So like in college, one of the things we encourage you to do is to test out your beliefs, to form what your values are and what your beliefs about the world are, and to meet other people and to exchange these views and to question them and to debate them with each other and maybe try out for size things you're not sure you really believe in. But let's just see where it takes us and talk it over with other people. And that kind of exploration, I think, is like incredibly valuable. To make that possible, it has to be safe for you to do that. So if we're in a world where everything you ever say to anyone is known and could be held against you 20 years later because you said one dumb thing to your friend that, 20 years later you no longer believe in. But you're going to run for, Senate, and now this is going to be, held up, or this old Twitter post from 20 years ago is going to be used to just destroy your life. Then it's really hard for people to feel comfortable and safe doing that kind of exploration, and then we all lose. So that's another way that privacy is really important. Cancel culture, basically, to try to protect yourself, to be able to have this kind of conversations about delicate topics where you're not really sure where your view is, or where, maybe you come to be persuaded to change your mind. That's really important that people be able to have that kind of interactions. This is how we learn and grow. Okay, so those are some reasons for privacy, some technology trends that I think the reasons why it might make particular relevance to your generation. What we're seeing is that technology is allowing more and more collection of data. It's becoming cheaper and cheaper to do that. So for instance, surveillance cameras are coming cheaper and cheaper. In London, we have surveillance cameras all around. And what enabled that primarily because it was cheap enough that it became feasible to do that. Drones are becoming cheaper. So now every protest is recorded. The police bring video cameras, or they have drones, or they have something that's recording what's going on. So now there's a recording of you at this protest. We have microphones are becoming cheaper. So we're going to see in our lifetime, probably, everyone's homes will have microphones in them. You'll be, there'll be microphones all around you. This is just part of the way things are. So these are technology trends. And I think privacy advocates, one of the primary concerns that this brings up for them is that we're building up these architectures of persuasion, that people are kind of unaware of how they can be influenced, the nudged, when there's a lot of information about them that could be targeting messaging to you individually, what's going to resonate with you, to try to shift how you vote, or shift what product you buy, or change your opinions, or influence the culture, or disrupt another nation as a weapon. Yeah, this is kind of the trends that we see into the future. And I'm hoping to teach you about this so that you can raise your awareness. I think all of you are going to go into the world. You're going to work with large data sets. Some of you maybe have access to data about lots of users. And I want to get you thinking in advance about how to protect the interests of the people that you have data about. And I thought to do that, I would do a worked example. I wanted to show you an example from the city of Oakland. They did a pilot a couple of years back with automated license plate readers. So this is a pretty cool technology. They put a camera. Remember how I said cameras are getting cheaper? They put a camera on cop cars that was, as the car was driving down the road, it would just be taking image constantly. And whenever saw a car license plate, it would read what was on the license plate number and store that into a database. I saw this car at this GPS location at this time. And keep a record of this, which is a pretty intriguing capability for police. Like if your car gets stolen, they could just type the license plate in and find where was it last seen. If there's a crime that happened and they happen to know where the getaway car was, they could look for other sightings of that car, maybe try to track down the criminals. So potentially very useful to police, but also potentially a little bit interesting from a privacy perspective. And the reason I wanted to do this example was because I could get their data. So they released their data set. An activist requested their data set under the Freedom of Information Act. And so I want to look at that. I want to look at the data. We've got their data. And so let's look at it together. This is really cool. So here they did a pilot. So it wasn't on all the police cars. But here we've got the data. It's this massive file. If you try to run these demos, I didn't upload it because the file is too big. I only have it locally. Sorry. What's in this table? We can look at this table. I loaded it into one spreadsheet and then loaded it into a table, and we got this giant table. And check out the table. Look at that. Almost 3 million rows. Whoa. Big data set. Each row is one reading of a license plate. This was seen by some police car at some time. So you can see here is, these are weird labels, but this is the license plate number. This is the time it was seen. So this pilot was, 2011, longer, further back than I thought. And this was the GPS location where the car was seen. So probably where it's parked or whatever. Okay. So we're going to work with this data set. We're going to see what we can learn from this data set. I thought this was really fun to play around with. So the first thing I did, I said, I don't know what these weird labels are. So I relabeled the column headings to be something that makes sense to me. Plate number, timestamp, location. It's a lot of data. Now, maybe you can guess what the very first thing I did with this data set was. What would you do? Group it. Find my car. Yeah. I was like, oh, hey, let me go look for myself in this data set. I wonder if I'm in there. So I went looking for my license plate. Nope, not in there. It's mostly Oakland stuff, not very much in Berkeley. So, okay. All right. Yeah, visualized. Okay, all right. So that's what that's really what I did next. We should start to visualize this data. That makes sense. But I was curious, so I was like, okay, I couldn't find my license plate, so let me go just see someone else's license plate I can find. And I was trying to think, who should I look for? So I thought, public figures is probably fair game, right? So I looked up the mayor of Oakland, who at that time was Jean Quan, and I decided I wanted to find Jean Quan's car in there. So I found her license plate number, and so let's do a visualization of where Jean Quan's official city issued car is. By the way, kind of fun. How did I find out her license plate number? I did a Google search. And I found a news article that reported that she had a bunch of unpaid parking tickets, and let me show you the picture in this news article. It shows her car parked there, and so there's her license plate. Okay, there's Jean Quan's license plate number. So we're going to now work with this data set and go find all rows with Jean Quan's official car license plate number. And everything's really slow when you're working with this larger data set, but there it is. Those are the six places where her car was seen. Not very many, because this is just a pilot. It was only a handful of police cars that had this installed, not the entire fleet. Okay, so her car had been observed 6 times during this pilot. Well, I don't know how to read GPS coordinates by eye, so I don't know anything about what this means. So I wanted to visualize it, and I thought a map would be a perfect way. So I'm going to display this on a map. To do that, I realized, this data isn't quite in the format I wanted. Yuck. I really need a column with a latitude and a column with a longitude, and that's not what I got. So this is very common when you're working with real data sets. One of the things you have to do is you got to clean the data. Maybe it's not quite in the format you want, so you got to convert it to the format you want. So here we have this string that has the GPS coordinates, and I need to convert that into 2 separate columns. So I wrote a little code to take this string and split it apart into the stuff before the comma and the stuff after the comma, and then it'll give me the latitude and the longitude. And just to give you some examples, like if you have a string like this, the get latitude function will give the latitude part, and the get longitude will give me the longitude part. And so now I can go modify the table and add those as extra columns. So I'm running that code. That's going to take about a minute to finish running. And then what I'm going to do after I've added that to the table is I'm going to find those 6 places where her license plate was seen, and I'm going to put it on a map. Okay, so I've got a new table here with this is split out into separate latitude and longitude columns. And then I draw the map, find all the places where her car was seen and draw it on a map. And we can now take a look at that map. And let's see if anyone knows Oakland can tell me what we're seeing and why this makes sense. Where is this? We see it. Her car's been seen a couple of times, maybe 3 times down here and maybe 1 time up here. Does anyone know what that is? Yeah, this is the police department down here. And this, I think, is maybe the mayor's offices or something like that. So these are the courts and the police system. So I think she's maybe kind of spending time at these 2 different city locations. So that makes sense. Yeah. Okay. Commuting back and forth, traveling back and forth in her city car between two places where she works. Okay. Now, notice that this is like headquarters where I would imagine she spends most of her time. And this is the police department. And she's been seen once up here near her, near these headquarters. But then the license plate was seen 3 times down here right by the police station. Any ideas why? I don't think she's spending more time at the police station than her headquarters. Maybe paying her parking tickets. I love it. I love it. I love it. She's down there paying her parking tickets. But no, seriously, more cops there. Yeah. This is where the police cars, where every police officer starts and ends their shift. There's a lot of police cars there. So for sure, you're going to have a lot of coverage, police cars driving through here. So if you park there, it's really likely you're going to end up in this database. Whereas they're probably not as often driving by any other spot that's far away, like her headquarters. And so even though she spends more time up there, there's more reads down here. So this is telling us that this data set is biased. So when you got a data set, good thing to understand is what are the biases in it? And we can see there's kind of an observational bias here that we're going to see more instances in the places where the cops spend more of their time. And for instance, the ACLU used this to measure where did the police spend their time and found that they spent a disproportionate amount of time in certain neighborhoods and not others. And okay, so that's a very interesting, another way you could look at this data set. That's not where I'm going to go with this. All right, so I found Jing Kwan's car. So next I started poking around. Who else can I find in this data set? And there aren't any names, so I had to figure out license plates of individual people. So I kept looking around and I found I found some more, and I decided I was going to make a better visualization as I started to find some more examples. I decided I was going to color different colors. One color for weekend, one color for weekday daytime, and one color for weekday in the evening. And then I went and I found the fire chief. I was like, oh, okay, the fire chief also gets issued a car. So let's go look and see where that car is seen. So now before this map comes up while it's computing, any ideas why I wanted to color code like this? Why are these different categories interesting? Not working on the weekends. So yeah, if we see during the weekday, during daytime, that might be the work location. If you say weekends, yeah, if we see where this car is observed on the weekends, that's going to tell us a different kind of information. That might tell us where she spends her time on her own time or where she lives. So let's see what we can learn when we go look at this map as soon as the computer finishes processing. And what about weekday nights? Also probably, yeah, maybe where they live or where they spend dinner or something like that. Beware of outliers. Their kids' school. Yeah, if it's like 6 p.m., maybe they're picking up, I don't know, picking up their kids. If it's like 7, 8 p.m., maybe they're visiting a friend for dinner. Some people could be working on the weekends. Yeah, this is definitely not going to be a surefire thing. We're kind of drawing guesses, inferences. All right, so here's the map. All right, so let me remind myself of the color coding. Blue was weekday daytime. All right, so let's start with a blue and see what we can infer about the fire chief from blue. All right, what do we see in here? I don't know if any of you know this area of Oakland, but this turns out to be city offices. So I think that's probably her office. I think I remember looking it up and that was like, oh, it turns out that's where the fire department's headquarters are or something like that. Okay, so that makes sense. Daytime parked a lot of the time near her office. All right, so red was weekday evenings. So let's take a look at these. Here we can see 2 of them. Here's one 6 p.m. on a weekday evening. Here's one 11:17 p.m. Any guesses what those might represent? Could be where she lives. Could be she went out to get food and got takeout or went to a restaurant. Could be visiting a friend. Maybe there was a fire and she went there. It's hard to know. This is a fire station? Oh, I didn't know that. That's interesting. Could be an affair. Yeah, that would really start to get a little creepy. And then I think I said green was weekend. So let's go take a look at this one over here. We have 11:52 p.m. I think that's a Saturday night. And we can zoom right in. Where do you think this is? I bet that's her home. This is a really posh neighborhood up in the hills. In fact, one of the things that I did, you can see the street numbers here, was I went into Google Maps Street View, and I don't know where she lives. I'm guessing it's probably one of these homes here. And I just pulled that up and I took a look at these homes here. So I probably narrowed down where she lives to within like one or two houses. So that's pretty weird. That from this data set that you might think is nothing really sensitive, is just people's cars, anything that could be publicly observed about them. I'm starting to learn things like, where does the fire chief live? Maybe something she didn't want public. Okay, so then I kept looking, starting to get a little weird here. And I just picked another person here. I thought maybe it's interesting to see what we can infer, what kind of inferences you can draw from this kind of data set. You thought that was the creepiest thing you've learned. Just wait, it gets better. Yeah, this feels a little weird, doesn't it? All right, so what you can see from this, whoa, holy cow. Like there's some serious, this person, I don't know. I mean, are they like an Uber driver? Are they like a taxi driver? Like they're all around. Are they doing delivery for restaurants? And then I thought I would zoom in on this area down here. And wow, they've been seen, their car's been seen a lot. And anyone have any explanations for what you think this represents? I would guess this is maybe where they live, that they're parking on the street where they live. And they've seen you around midnight, and it's an awful lot. So, okay, so we found out maybe something about that person. I don't know. It's hard to know exactly what's going on, but that was interesting. Here's another. I'm going to do another. It's kind of interesting to look at these and see what you can see from this data set. What information gets revealed about people from this data set? All right. What do the red, blue, green mean again? Let's see. Red means weekday evening. Blue means weekday, like Monday through Friday during daytime. And then green means weekend. And we can kind of zoom in over here on this person. So let's start this big cluster. We've seen their car was seen a lot over here. So let's zoom in here. What do you think I can infer from this cluster right here? What do you think that tells me? I mean, what would you guess? Place of work? Well, I don't know. I've seen these green ones. Those are like 11 a.m. on a weekend. I'm seeing blue ones here, which is like nighttime. 11. Okay. Yeah. There's red daytime, evening, weekend, all the time. So I'm going to guess this is where they live. I think this is the most common place seeing where your car is probably where you park it. And where does your car spend most of the time parked is where you live. So I think we found someone who lives approximately this corner. I don't know who that is. Now I want to go look at this cluster over here. Does anyone know where this is? Does anyone who know it was Oakland know approximately where this is? Where am I looking at? Laney. This is right by Laney College. Yeah, there's Laney College over here. And then there's a bunch of dorms over here and apartments. The Laney students tend to live there. You can see some of the fields for Laney College. And if we start to look at these, we see 12:21 a.m., so midnight. We see 1:44 a.m. We see 1:44 a.m. We see 7:08 a.m. We see 7:08 a.m., 12:08 p.m. So this 9:43 a.m. These are their car being seen probably parked overnight. And then I started to realize what I was seeing here. We could make some guesses. What does this indicate? They live somewhere else, but occasionally their car is seen parked overnight here. I'm wondering if we're seeing, is this a boyfriend, girlfriend? They're visiting, they're staying overnight with their boyfriend, girlfriend. And that was when I realized I got the feeling like I had just gone too far. I learned someone about where they live, that they're dating a Laney student, and that they seem to be staying overnight there, and like some individual times. That was a lot of information to learn about someone who probably has no idea that we're staring at their data. So talk about creepy. That's pretty creepy. Pretty scary stuff. All right. So I think at this point, I decided I'm not looking anymore. I've had enough of this. This doesn't feel right. This doesn't feel comfortable. But I wanted you to have the experience so you could see viscerally for yourself how what looks like fairly innocuous information can reveal some fairly private stuff about people's lives. So I hope that you, in your future career as data scientists, will think about how the data you have might affect people's lives, and think about how to protect it so that you don't cause harm to people who's you got data about. And if you want to read the demos, I've got some notes here about some candidate ways you could protect data and be respectful towards people. But mostly I wanted to get you thinking about this. Thank you very much for coming to lecture today. It's great seeing all your comments in the chat. And I will see you for our last lecture on Friday.